Looking at a brief glimpse at what quantum gravity is all about, based on an article that I came across from Scientific America, this year pretty much borrows heavily on three big questions to think about, and these questions they rely on each other. And the first one here focuses on how can we explain gravity's quantum nature, and once we're able to tap into this, then we can explain the early universe and also diving into what the deep interior of a black hole looks like. And so this here is quite an interesting foundation and also a futuristic understanding of what quantum gravity and its potential is going to offer to us. Now, what is quantum gravity? I mean, even the name itself says it all, and pretty much it just focuses on quantum behavior in gravity. And right now, currently, people are trying to say that gravity is not really real, and so we should quietly use space time as an alternative to gravity. So it's quite interesting to see that argument and somehow compelling in some ways, but thanks to couple of old, I would say, but most recent, I would say, understanding of gravity, thanks to Einstein's general theory of relativity. This year has really done a great job in explaining a couple of incredible phenomena that we have observed pretty much outside of our Earth region, which is in this case space. Like for example, light bending, as you can see through James Webb telescope. Another one we've looked at is Mercury's orbit. It also best explains black holes, how they are formed, and looking at gravitational waves. Now, looking at this particular bracket here, which focuses on quantum behavior in gravity, this has led to a massive question, which is space-time quantum? And this question here, the article dives into details on various experiments which we're going to look at on previous video, and proposed experiment and open experiments that we can build on to hopefully tap into generating environments that is quantum like, and how integrating gravity will show maybe some changes in quantum behavior, or how gravity can actually have some changes in its nature. So quite interesting to look at those in future videos. But now, for quantum gravity, this can be observed, which includes the following. First is you can observe quantum gravity in stellar dynamics, followed by cosmological formation of galaxy clusters, and currently in the works lab experiments on Earth's gravity effect on quantum systems. Now, looking at all these three observations on quantum gravity, the results show the same theme, which is that gravity behaves in a classical way and less of a quantum mechanical way. And so now we have this particular result. How can we be able to tap into gravity potentially having a quantum mechanical way? And this particular question, if it is answered in a positive way, that means that it's going to really change our understanding of what gravity is, and less of classical and more quantum mechanical. Now, moving on to the theories that are around quantum gravity. Currently there is no established theory, and we need to be aware that there are contending theories out there that is trying to pose how quantum gravity theories can be envisioned. And the first one here is known as the loop quantum gravity, and pretty much this here, as it is stated, a loop, it shows a kind of a fabric of space and time that is woven from networks of thin fabrics loops, and this here is kind of suggesting that space and time is not continuous, but rather it is a little bit more granular in nature. And on the other side here, the string theory pretty much focuses on interpreting how particles can be envisioned, which is more of fundamentally being a vibrating string. And so this here is more of on a little low key state in terms of not really too reliable, or a lot of scrutiny that is surrounding this. And this one is a little bit much more fascinating in terms of current research going on. But the challenge here is based on the difficulty of determining what experiments can be done to test these two theories. And this here is because of how difficult it is to recreate environmental conditions like or accessing the black hole. I mean, to go to a black hole would take you like a lot of light years to achieve that. But most importantly, if you get into a black hole, you have to envision how the interior is going to look like. That is really a big challenge. But also with the current telescope and observatories improvements that we are getting closer to looking at how the early universe potentially may look like, but we still have a long way to go to actually achieve that. But then looking at the early universe before the Big Bang, how were the subatomic particles behaving in that particular at that particular time before the eventual Big Bang actually sprung up. So those are really the things that is really difficult to tap into right now, but we will see how the future will help us to achieve this particular understanding. But then there are proposed experiments that are out there that may help us to tap into understanding what quantum gravity or whether this existence is actually possible. And this proposed experiment introduces some conditions that includes the following. One is that you need to have a low energy system. Why do we need a low energy system? The reason why is because we need to access potentially any form of strings, loops, or this is a big one, quantization of gravity. And this pretty much means, do we have discrete levels of gravity or discrete positions? And if we have something like that based on energies access, then that means that gravity do exist as, or gravity is quantum, which is going to be a big deal. So it's going to be fascinating to see all these particular details on experiments, proposed experiments that may require a lot of huge investments and also future goals that will be set up to enable us to answer this big question on whether what gravity is quantum. So watch out for my next videos on those particular conversations, and go down into the comment section and let me know your thought about quantum gravity. Do you think that our gravity right now, because we are currently observers, we don't do you think that we actually have a quantum gravity that we are subjected to, but we can't really sense it? Or do you think no, gravity is more classical? Anyways, drop down into the comment section and let me know your thought about this. And see you on the next one. Stay smart as always and believe in yourselves.